Hi dear students, welcome to my YouTube channel. Today's topic is part 4 heating effect of electric current from chapter 4 current electricity. So let us understand heating effect of electric current. So whenever electric current flows through a conductor, it gets heated. That is, we say that electric energy gets converted into heat energy. There are various electric appliances in our home or daily life where this effect can be used. For example, electric lamps, soldering gun, iron, heater, oven, etc. So why conductor gets heated whenever electric energy, or we say that whenever a current flows through a conductor, heat is generated across it. So why this happens? So in conductors, electric current flows due to the flow of electrons between atoms. So flow of electrons, we say that it is electric current. So as electrons move through a conductor, some electrons collide with atoms, other electrons or impurities. So the colliding electrons transfer their energy to it to that atom in during this collision, and we know that temperature is the measure of average kinetic energy in the system. Therefore, as more electrons collide with atoms, we say that the conductor gains more kinetic energy and therefore its temperature increases. That's why we say that conductor gets heated. So the amount of heat energy generated here, it is given by Joule's law of electric heating. So Joule's law of electric heating states that the amount of heat energy, capital H, due to the flow of current through a conductor is directly proportional to three factors. First, square of current, resistance of the conductor, and third, time for which current flows. So combining all these three, we say that H is directly proportional to I square RT. We always take a constant here and remove the proportionality symbol, and the constant in this case we write as 1 upon J, or same equation can be written as J is equal to I square RT upon H, or VIT upon H, or V square T upon RH. Here capital J is called as Joule's constant, or it is mechanical equivalent of heat. Its value is 4200 Joule per kilocalorie, or 4.2 Joule per calorie. Now let us study the electric fuse, the working of electric fuse. So electric fuse, a safety device. It is a safety device. It is used to protect circuits and various appliances by stopping the flow of any unduly high electric current. So generally electric fuse, it works on the heating effect of electric current. Electric fuse, it consists of a piece of wire made up of metal or an alloy of appropriate melting point. For example, aluminium, copper, iron, lead, etc. And this electric fuse is always placed in series with the device. So whenever a current larger than the specified value, it flows to a circuit, the temperature of the fuse wire increases because of the heating effect of electric current, and this melts the fuse wire and breaks the circuit. And that's why we say that electric fuse, it is a safety device. Electric energy and power. So generally we define power as rate of doing work, and this is also the rate of consumption of energy. We have equation H is equal to I square RT. It gives the rate at which electric energy is dissipated or consumed in an electric circuit. So this is termed as electric power. So electric power is defined as the product of voltage into current, that is P is equal to V into I. SI unit of electric power is watt. Since electric energy is the product of power and time, the unit of electric energy is watt hour. 1 watt hour is the energy consumed when 1 watt of power is used for 1 hour. And the commercial unit of electric energy is kilowatt hour, which is commonly known as unit. So now whenever we have to solve problems, we have certain formulas here. We have capital H is equal to I square RT upon J, or VIT upon J, or V square T upon RJ, where H is the amount of heat conducted. It may be in calorie or kilocalorie depending upon the value of Joule's constant. Capital I is current in ampere, V is potential difference or voltage in volt, R is resistance in ohm, and T is time taken in second. If it is given in minute or hours, we have to convert it to seconds. Capital J is Joule's constant. Its value can be taken as 4200 Joule per kilocalorie, or it may be taken as 4.2 Joule per calorie. So let us have first problem. Calculate the amount of heat generated when a current of 2 ampere flows for 5 minutes through a resistance of 5.2 ohm. Joule's constant is given 4200 Joule per kilocalorie. So let us write first given things. So we have to calculate amount of heat generated, that is capital H. current of 2 ampere given, so capital I is equal to 2 ampere for 5 minutes, so time t is equal to 5 minutes, convert to second, so 5 into 60, that is 300 second. Resistance of 5.2 ohm is given, so capital R is equal to 5.2 ohm. Value of Joule's constant is also given. So with this given data, we can now find out the amount of heat generated using formula H is equal to I square RT upon J. Just substitute all the values, you will get amount of heat generated as 1.49 kilocalorie. Let us solve second problem. An electric geyser of 150 ohm generates 550 kilocalorie heat in 30 minutes. What is the voltage of mains? So first we will write the given data. Electric geyser of 150 ohm, so R is equal to 150 ohm. 550 kilocalorie of heat is given, so amount of heat generated H is 550 kilocalorie. Time is given 30 minutes, convert to second, 30 into 60, that is 1800 second. We have to find out voltage of mains, that is capital V. Now we can take value of Joule's constant. Here H is given in kilocalorie, so we will take Joule's constant as 4200 joule per kilocalorie. So with this data, we will write formula for heat generated as H is equal to V square T upon Rj. From that we can write V square is equal to HRJ upon T, take a square root, substitute all the values, you will get voltage means it is as 439 volt. Now let us study certain MCQs related with this heating effect of electric current and Joule's law. So as per Joule's law of electric heating, the valid equation is, so Joule's equation, we know that it is H is equal to I square RT upon J, that is option B. The production of heat energy in a conductor due to electric current flowing through it called. So this is heating effect of electric current. Heat generated in a conductor carrying current depends on. So according to Joule's law of electric heating, heat generated depends upon current, resistance and time. So correct option here, it is option D, all of these. The mechanical equivalent of heat, capital J, is equal to, we know that Joule's constant or mechanical equivalent of heat is given by 4.2 joule per calorie, or it is 4200 joule per kilocalorie. So both options A and B are correct. So option D is correct here. Electric fuse works on the principle of dash dash effect of electric current. So electric fuse, it works on the principle of heating effect of electric current. The electric meter measures the amount of electricity used in. So electric energy, its unit, we write its unit as kilowatt hour. Heating effect of electric current is used in, so it is used in electric kettle. Product of voltage and current is known as, it is power. According to dash dash law, when current flows through a conductor, it produces heat in it. So current flowing through a conductor, it produces heat. This is Joule's law of electric heating. According to Joule's law, dash dash energy is converted into dash dash energy. So according to Joule's law, whenever a current flows through a conductor, it gets heated. That is, in this case, electric energy gets converted into heat energy. According to Joule's law, heat generated in the current conductor is not directly proportional to. So Joule's law states that heat generated is directly proportional to square of current, resistance and time, but it is not directly proportional to length. So problem is given, an electric iron of 50 ohm generates 378 kilocalorie of heat in 30 minutes. What is the voltage of mains? So we will write formula first here, that is H is equal to V square T upon Rj. We have to find out voltage of mains, so we write V square is equal to HRJ upon T. H, amount of heat generated, it is 378 kilocalorie. Resistance R is 50 ohm. Joule's constant is given 4200. Time T is 30 minutes. We have to convert it into seconds, that is 30 into 60. So substitute the values and take a square root. You will get value of voltage of mains as 210 volt. So option B is correct. Find the heat generated in calorie if a current of 1 ampere is passed through a coil of resistance 836 ohm for 1 minute. Value of Joule's constant is given 4.18 Joule per calorie. So we have to find out amount of heat generated. So we use the formula H is equal to I square RT upon J. Current given here is 1 ampere. Resistance R, it is 836 ohm. Time is 1 minute, that is 60 seconds. Value of Joule's constant is 4.18. Just substitute all the values. You will get amount of heat generated as 12,000 calorie. So option D is correct. Find the time required in minute to produce 2400 calorie of heat when a current of 2 ampere flows through a wire of resistance 4.18 ohm. Again, value of Joule's constant is given 4.18 Joule per calorie. So we'll first write the formula for amount of heat generated as H is equal to I square RT upon J. From that we say that time T is H into J upon I square R. Amount of heat generated, capital H, it is 2400 calorie. Joule's constant is 4.18. Current I, it is 2 ampere and resistance is 4.18 ohm. So substituting all the values, you will get time T as 600 seconds. We have to convert in minutes. So just divide it by 60, you will get 10 minutes. So option B is correct here. Thank you very much. If you like this video, you can like and subscribe to my YouTube channel. Thank you very much.